This is for Math 117. It's homework from section 1.1. It's the second set, 1.1b. So I wanted to talk about a few things. You're allowed to submit each one of the blanks, answer blanks, in these homework assignments 5 times, unless it's like multiple choice and there are only 4 multiple choices there. If I touch one of these numbers, it actually takes me to the number that I touch. And I can do Control Home and it'll take me back up to the top of the page. Control and then the home key is what I touched. And it might be Control Up will work for you too. When I go to look at a problem here, I guess this might be a little bit small on the video, so I'm going to bump this up. If I hold down the Control button, Command I think it is for Apple computers. So Control plus, it's going to bump the size up, and then I can also do Control minus to bump it back. But let me bump it up so that we can actually see what we're doing. On these exercises, I want to simplify the expression here, assuming that x and y are positive. That usually means no negative exponents, but it might let me get away with it. So I want to play with this for a little bit and see what I can get away with. So I'm going to put a fraction in, and I can see this is going to be 11 over 5 for sure. That doesn't reduce. If I do x, that's going to be subtracting those. 8 minus 4 is going to give me to the, and I can do the to the key here, or I can do the to the, oops, wrong button. Control Z doesn't take me back, but if I hit backspace, I can get back. So I want to do the to the here, and I get, what did I say? 8 minus 4 is 4. And then to get out of that, I need to go over with my cursor. And I'll do y to the, it looks like negative 4, right? Y to the, and I could hit the caret key on the keyboard. So that's Shift 6 on my keyboard. That'll be 3 minus 7 is negative 4. And I'm going to see if that works. I don't think it's going to because I usually want negative exponents, but it might. So I'm going to submit the answer and see if that works. And they let me get away with that negative exponent, so that was fine. But if it says no negative exponents, you wouldn't be able to leave that. Now, if I wanted to work it again, I could get rid of this and work it again. But I'm going to show you practice another version here. So if you're having trouble with this, it pops out a little pop-up like this. And I'm going to open it up so that we can see it. And I get another chance to try this again. So if I had trouble with this, I might come in here and try it again. But you could grade it. And it doesn't like to do grade this without something in here. So I could just put a number in here and do grade this. It'll tell me it's wrong, and then I can show the answer. And there's the answer, 11x to the 4th. And if I hide the answer, it might let me show the solution. I'll try that one more time. At some point, it might show me a solution and let me try it again. So depending upon what it is, there's not a whole lot of solution going on here, but you can see what the answer was expected to be, especially if you're not quite sure what things are and where you might be making a mistake. You're allowed 5 times. If you miss it the first time, you might come in here and see what they're expecting, because it could be that you're not giving a fraction when you should be, or you're giving negative exponents when you shouldn't be. So the first few of these are really just like the first examples we did in the 1.1a video. We want to simplify the expression. So here, I may not know what e is. This is going to be covered in our course in chapter, well, I think we look at it in chapter 3 maybe for the first time. But e is just a number. This would be like 3 to the x, 3 to the x minus 2. So all I'm doing is multiplying the exponent. I can copy and paste like this. And it doesn't give me what I wanted it to, but then I can come in and put in what I do need to the x. So it wasn't very helpful on this problem, but I can use that sometimes to copy and paste. So let me get rid of this. It doesn't say that I need to have positive exponents, so I could just put this in and I end up with e to the, this is going to be x over 2, so I want a fraction up here, and it needs to be negative x over 2 over 2. The down arrow will help me get to the 2. And then this will also be e to the, and this needs to have parentheses, so let me put some parentheses in here. and I want to put x minus 2 times negative 1/2. Let me see if I can get away with this, because it says simplify. It may let me get away with x minus 2 and then divide this by 2. And I might even put a negative 2 here. I'll submit the answer and see if that works. And it didn't like it, so that means they want it simplified a little better than what I have it simplified. So I'm going to come over in here and solve this problem and simplify it before. So this actually means e to the x minus x minus 2. So I'm just subtracting the exponents. I have the same base, I can subtract the exponents, raised to the negative 1/2 power. And that's the same as e to the x minus x plus 2, being careful with the negative being distributed here. Remember that you have to distribute. And this will be times a negative 1/2. So this will give me e to the 2 times negative 1/2, because this part's 0. So 2 times negative 1/2 is going to give me e to the, and if you need to, go to your calculator and multiply this. This will give me e to the negative 1st power. So we'll try that. That looks like a pretty good simplification. So e to the negative 1st power. It doesn't mention whether or not I can have exponents. Negative. So I submit the answer, and it says no, it doesn't like that. So we'll try my 1 over e, because e to the negative 1 is the same as 1 over e. E is just a number. This will be 1. And then we'll put in e. E is a number. It looks like a letter. And that's right. So for each of these, you want to be careful about what things look like. And I could have gone in here, submitted an incorrect answer. Let's see what it actually gives when I submit my answer. And it's wrong. And here it's not giving me an option to help me with this. So you can see I'm not going to be able to get another one to help me. This does take the best answer. So if you had it right and then you go back and do it again, you have it wrong, it should take the best answer. Although right now it's telling me 0 of 1 points. So let me try putting this in. I'm in an instructor version, so it works a little differently than yours. And now it's telling me I have all the points. So all of these are simplifying this expression, and probably you're not going to want to leave negative exponents. We did one like this yesterday, but again, you're not going to probably want to leave those negative exponents. Remember that the square root of 49 would give me 7, and then it'd be 8 divided by 2, because there's an automatic 2 understood if there's not a number when you have a radical like this, and negative 6 divided by 2. They give me negative 3, which means I need y to the 3rd in the denominator. For number 7, I'm not really sure what they're going to want the answer to look like, so I'm going to practice another version. And I'll try, this is the 4th root of x to the 4a, which is going to give me x to the a divided by 2. Oops, I always hit the wrong one. X to the a divided by 2. And notice if I hit the forward slash, the divide sign is going to give me that divided. And then we're going to have, actually it's not divided by 2, is it? I must mess that up. So it'd be a plus b divided by 4. I don't know where I got it. I don't know where I got that 2. I was sure it was 2 when I was saying it 2. So I'm going to grade it. And that's exactly what they're looking for. So you get an idea of what they're expecting you to do with the exponents there. I'm just dividing out, in this case, the 7 with this and simplifying the expression so that I can have it written like this. This one you're going to multiply these in, and actually you can't multiply these. This is a cube root and that's a square root, so be careful with that. Here they're wanting you to use the fact that 2 to the 1/2 is 1.414. So they want you to evaluate this expression without using a calculator. So 32 to the 1/2, where 2 to the 1/2 is 1.414, well, 32 is actually 2 to the 5th. So I want to do 2 to the 1/2 to the 5th time. So I'm going to put this number in and do it to the 5th time, and that will give me the answer they're looking for here. The same is true here. They want 7 to the 1/2 is this, 2 to the 1/2 is this. So they're going to separate this as 2 and 7. So that would mean I'm just multiplying these two numbers. Don't overthink it. I will not ask you things like this on the test. All you're going to see is them on the homework. So it should take you just a few minutes to do those exercises. Rationalizing the denominator is a whole new set of things that we need to talk about. So I need to go over to my paper and actually work these out for you. Sometimes in your homework they'll ask you to rationalize the numerators. I won't have you do that on the test, but rationalizing the denominators you should do. So to rationalize, that just means get the radical out of the denominator. So square roots, cube roots, fourth roots. We want to get the radicals out of the denominators. But they can say rationalize the numerators, and I'll show you that too. I won't ask you that on the test, but you will need to do it on this assignment. So if I have, for example, 3 over the square root of x. To rationalize, I need to multiply by just enough to get rid of the square root of x in the denominator. So square root of x times square root of x. This is the number 1. I can always multiply by 1. There's a rule of algebra that allows that. This is going to give me 3 square root of x in the numerator, and it's going to give me the square root of x squared down here, which is just x. Technically, it's absolute value of x, but I'm not going to worry about that here. If I have something a little fancier, 3x squared, let's do 13x squared over the square root of x, y, z. Then here I'm going to want to multiply by the square root of x, y, z. This I'm just going to multiply across 13x squared, square root of x, y, z. And then square root times square root is just going to pop the stuff out. They're inverse functions of each other. And it just pops it out, so I end up with x, y, z there. But now I notice if I want to simplify this completely, they share an x. These cannot be simplified. A radical, two things that are not under radicals, cannot be simplified. But I can get rid of one of the x's here. So this would be x squared divided by x is just an x, with x, y, z in the denominator. You could also have a problem where everything is under one radical. So if I had something like the square root of 5x over 7y, and I wanted to rationalize the denominator here, then I'm just going to multiply by enough to get rid of the radical in the denominator. This actually means the square root of 5x over the square root of 7y. And of course, you want to see if you could reduce in here, but I couldn't have. But if you could have reduced this, you would have reduced that first. So I'm going to multiply by just enough, square root of 7y. And these are both square roots, so I can multiply the two of them there. So I end up with the square root of 35xy over 7y. So the square root of the same thing here, two square roots multiplied, same thing under them, is going to pop that out from underneath the square root. Now it doesn't have to be a square root, it could be a cube root. So for example, if I had 7 over the cube root of 3x, I would need to multiply by just enough to make this a perfect cube. Here I was doing perfect squares, because these were square roots. I need a perfect cube here. So to get a perfect cube, I would need this 3 times. And I could do it cube root of 3x, cube root of 3x. So that emphasizes I have this 3 times, so my denominator will become 3x, because doing it 3 times will just pop it out. Cube root of 3x quantity cubed is going to give me just 3x. Now up here, these two together, and you could have just written the cube root of 3x squared, so if you understand what you're doing there, you could do that. These two together will give me 7, and this will be the cube root of 3x squared, but that's the same as writing 7 cube root of 9x squared over 3x. Now you have one where they're asking you to rationalize a numerator, so let me show you that briefly. So if I have a cube root in the numerator, a cube root of yz squared over 5, and I want to rationalize the numerator, I need to multiply by just enough to make this a perfect cube, but notice I already have a square here, so just enough means that I'm going to need a cube root of, I have 1y, I need 3 of them, so that means I need 2 more. I have 2 z's, I need 1 of them, I need 1 more. I recommend that if this is not making a whole lot of sense to you, that you go back through and study this a few more times until it actually does make sense. So on the bottom, we're also multiplying by the cube root of y squared z. And this is rationalizing the numerator. We usually rationalize the denominators. I will not make you do the numerator on the test, but you do have to do it for the exercise problems. So on the top, I pop out that y and z. I'm just popping out a y and a z here because when I do y cubed and take a cube root, I get a y. Z squared times z will give me z cubed. Take a cube root, I get a z. So this becomes 5 cube root of y squared z. So you'll rationalize some numerators and denominators all the way through problem number 16. 17 is a little different. So here we're going to be performing the operations. I've just got things in parentheses added to some other things in parentheses. So this should be very easy for you. It's collecting like terms, no problems at all. Let me know if you have problems and we can discuss it, even in class, if you want to discuss it there. Here, notice that there's a negative. So perform the indicative operations as a negative. I can just drop these parentheses, but this negative means that I have to switch all the signs all the way across. So I have a minus y squared plus 4y plus 8. So be very careful when you're distributing negatives that you distribute those correctly. You have the same kind of distribution going on here. I'm going to distribute the pebble in the front here, the number that's on the outside. 3 into here is going to give me 28a minus 3b. Notice here I'm distributing in negative 6. So I'll get negative 6b plus 48a. If you need to, if you've forgotten what 6 times 8 is, make sure you're getting out your calculator and making all these numbers correct. The number 20 here, it says perform the indicated operations. Well, this is a bunch of things inside of each other. So you're going to always start with the innermost one. So 3x minus 7 does not simplify, but I do have to travel this negative through. So you want to write this down on a piece of paper and one step at a time, do these steps out. Perform the indicated operations and simplify. Here they're going to want you to keep the fractions, so you can do these fractions on your calculator. Negative 5/4. Second quit out of here. So I have negative 5 divided by 4. And I can see that's with the y. And I'm going to add a 1 divided by 4. And I want it to be a fraction, so I'll do math, enter. And it gives me negative 1, which is what I thought it should have been. But it might have been a different number than that. 1/4 and 1/8 is going to give me a fraction for sure. So make sure you're using your calculator if you're going to have trouble adding or subtracting numbers. Perform the indicative operation. This is just FOIL. They want you to simplify, so there's going to be middle terms that you have to simplify. So I end up with 20x squared. Outer would be 4 times 9 is negative 36x. Inner is 6 times 5 is 30x. And last would be 6 times negative 9 is negative 54. And then I want to combine the two that had x terms. So make sure you're writing these out so that you can see what you're doing. This one is squaring, and you should know some formulas about how to square things like this, but you could just write these as two separate ones. You can't distribute the two because these are not multiplied. They have to be multiplied or divided for you to be able to distribute that too. So let's talk about the formulas for doing this and work an example. Now I asked you for these formulas on the first test, so you should be able to do the factor formulas, and there's 5 that you should have memorized. So the first one is to factor a squared plus b squared. This is actually prime. Factor formulas. And these are factor or product. So we're doing actually the product part. And then a squared minus b squared, factors, or when you multiply a plus b times a minus b, you end up with a squared minus b squared. Then we also have a squared plus 2ab plus b squared is equal to a plus b squared. So this formula we're about to use, and a squared minus 2ab plus b squared is equal to a minus b squared. Now, like I said, you're going to be responsible for giving me these factor formulas, so you need to be able to know these by heart when you come to the first test, which is factored, and I will be able to see what you have on your desk. Which is proctored. The last two that we need are the cube formulas. So a cubed plus b cubed and a cubed minus b cubed. This is a plus b. This one's a minus b. And then there's a form I'm filling in here. I definitely need an a squared and a b squared, and both of those are positive. This looks like these formulas, but it's not. So be careful that you don't put a 2 in there. This should have a minus because I'm changing the sign here, AB. So I'm going to do the square of the first, change the sign, multiply, and then add the square of the last. Square of the first, change the sign, multiply, and add the square of the last. So those 5 formulas you should know. So using this formula that we have problems on right now, if I have 3a plus 5b squared, this actually means 3a squared, using the formula, a squared plus 2 times, this is my a and my b, so this is 3a times 5b plus the last one squared, 5b squared, and it says to simplify, so I have 9a squared plus 2 times 3 is 6 times 5 is 30. AB plus 5 squared is 25b squared. And you could have skipped to this step if you understand how the formulas work. So memorize the formulas, I'll ask you for them, and then I'll ask you to be able to use them like this. Let's work another one with the subtraction formula, a minus b. So if I have 7x minus 3y, and I want it squared, this will give me 7x squared minus, now these are the same signs here. Like these are also the same signs, but the second one I change it. But these, they're the same sign in that second position, and there is a 2. The first term, the second term, plus the last term. So this is an a minus b squared. So this is my a, and this is my b. So this becomes 49x squared minus 2 times 7 is 14 times 3 is 42xy. Again, pick up your calculator if you're going to get these wrong. Let that calculator work for you. 3 squared is 9y squared. Everyone knows that at some point you were tested on whether or not you could do your multiplication tables. This class is not testing you on that. It's testing you on whether or not you can do things using a calculator. All right. So that'll take care of a couple more problems here. The next one again is FOIL. And I guess I should show you an example of FOIL because I keep mentioning it, but you might not actually remember it. So let's do an example of FOIL. If I have 7x plus 3y times 2x minus 5y. I'm foiling first, outer, inner, last. So the first would be the first two terms here. 7 times 2 gives me 14x squared. The outer would be 7x times a negative 5y, which would be negative 35xy. The inner is these two. Those are those two. So first, outer, inner, and last is what we're doing. So I'm on the inner part, so 3y times 2x, and I usually put these in alphabetical order, but it's not necessary, plus 6xy. I'm not picky about alphabetical order on these, or even order in terms of the terms. And then the last one is, the last would be 3y times a negative 5y, which gives me minus 15xy. So if we collect like terms, sorry, this should be 15y squared. It didn't feel right. So be careful. I'm going to go back through and make sure, because I just made a mistake and I'm feeling a little funny about it. So I'm going to go back through. So it's 14x squared. First, outer would be negative 35xy. Inner would be these, plus 6xy. And last would be 3 times 5 is 15, and it's negative. Plus times negative is negative. Plus times minus, we get negative 15y squared. So that looks good. Notice I can collect these. So I get 14x squared. You can't always. These could have been x and z here, in which case I wouldn't be able to collect them because I'd have x's and z's. So 14x squared minus 35 plus 6 is going to give me a minus 29xy. Again, if you're going to miss these, make sure you pick up your calculator. Minus 15y squared. So that gives you an example. That concludes the lecture for 1.2. 1.1b. So you're ready to complete those exercises.